Hello and welcome back to PA Academy. So right now we are dealing with arrangement of identical objects. So in the previous part of this video we deal with arrangements of unidentical objects. So now we are dealing with identical objects, and this is the example. It says, in how many ways can the letters of the following word be arranged? So we have mathematics, classroom, momentum, committee, abracadabra. So how many ways can we arrange the letters of this word? So one thing that is unique about all these words is that some of them are repeated letters. If you look at, we have mathematics appearing 2 times. We have, for example, we have class appearing, S appearing twice, O appearing twice, M is appearing twice. Under momentum, we have M appearing 3 times. So unlike the previous example where there was no letter was repeating each other. So in doing this, let's start with question 1. That is mathematics. So the first thing we are going to do is we are going to count how many letters do we have in the word in total. So if you look at it, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we write our n to be 11. So then we look for how many repeated letters do we have. So if you look at this question closely, we have M. M is a repeated letter, so we have M appearing 1, 2. M is appearing 2 times, so let's note that we have 2M. So which other letter do we notice that is appearing more than once? A is also appearing more than once, that is 1, 2. Our A is 2, so let's note that 2A. So another thing, that's what else is appearing more than once? So our T, we have 1T, another T, 2T. So that is, I think that's all, yeah. So these are the M, A, and T. They are appearing twice. So in solving this, we are going to have it, look at this notation here. So we are going to have this as 11 permutation 2 factorial, 2 factorial, and 2 factorial. That's because we are having them appearing twice, that is more than once. So we note it here, equals to, so now we are going to have 11 factorial over 2 factorial times 2 factorial times 2 factorial. So now let's express this. So what we are going to be having is 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 factorial. Now note, I'm stopping at 2 factorial, and I'll tell you why. So all over, so let's do that of the denominator. We have 2 times 1, that is for this 2 factorial. Then the second one is times 2 times 1 times 2 factorial. You can see I also pick this one and stop at 2 factorial. The reason is that this 2 factorial can also cancel this 2 factorial. So instead of writing it as 2 times 1 and coming here write 2 times 1, you can just cancel it out from this point. So now let's simplify this. So we have 2 times 1 times 2 times 1, that's 4. So you can cancel all this and cancel 4 on this, on the numerator. So now we are going to multiply 11 times 10 times 9 times 8 times 7 times 6 times 5 times 3. So once we do that, we press that in our calculator, we should be having 4,909,600 then ways. So that's the solution to question number 1. So that means the word mathematics can be arranged in 4,989,600 ways. So that's the solution. Now let's go to question number 2. So the next one is classroom. So for classroom, let's see what is the value of our n. Our n, that is 1, 2, 3, 4, 5, 6, 7, 8, 9. So our n is 9. So let's look at which letter is appearing more than once. So we have, let's look at it. Our S is appearing twice. So we have S appearing twice. So we know, let's note that 2S. And then I think okay, and we have O appearing twice. So that is our O appearing twice. So those are the only letter that are appearing more than once. So let's put down the notation. That will be 9 permutation 2 factorial and 2 factorial equals to, so 9 factorial over 2 factorial multiplied by 2 factorial. So let's express it. So 9 factorial is written as 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 factorial. So I'm stopping at 2 factorial because the denominator too, we have 2 factorial. So over, let's expand the denominator. So we are going to be having 2 times 1 times 2 factorial. So let's break this down. 2 factorial can cancel 2 factorial. So we have 2 times 1, that's 2. So we can also cancel this, and then this 4, it can divide 4. 2 can divide 4, so we'll be left with 2. So now what we are going to do is multiply 9 times 8 times 7 times 6 times 5 times 2 and times 3. So let's do that. So pressing that on the calculator, we will arrive at 90,720 ways, and that is the answer to question number 2. So that means the word classroom can be rearranged in 90,720 ways. So don't forget adding ways at the end, ways, because the question is ways is there, in how many ways. So once you are through, just put 90,720 ways. Some question will not come out in this form, so you might not need to put ways, but once it requires you to put ways, add it to it. So now let's go to question to the next one. So the next question is momentum. So for momentum, our m, that's 1 2 3 4 5 6 7 8, is 8. So let's see how many letters are repeated. So for it, we have, I think it's only m. M is the only repeated letter here. So that means our m. Okay, so momentum. So momentum, I did a little correction. I wrote m here earlier, so it's supposed to be n. So for momentum, the only repeated letter here is m, and the m is appearing 3 times. That's 1 2 3. So our m is 3. So now let's do it. So that is, we have 8 permutation 3 factorial. So that will give us, so that's 8 factorial over 3 factorial. So that will be 8 times 7 times 6 times 5 times 4 times 3 factorial. So we are going to stop at 3 factorial because our denominator here is 3 factorial. The highest factorial here is 3 over, so we can just write 3 factorial. So with that, this can cancel this, and then we'll be left with 8 times 7 times 6 times 5 times 4. So if you should apply, if you multiply that, we are going to have, so that will give us 6,720 ways. So that means the word momentum can be arranged in 6,720 ways. So that is an arrangement of identical objects. So this is how you solve questions that deals with arrangement of identical objects. So I want you to attempt number 4 and number 5, committee, abracadabra. So and let me know in how many ways can these two words be rearranged. So let me know what your answer is in the comment section below. And in the next part of this video, we are going to be looking at arrangements with repetition. Yeah, so we are going to be looking at arrangements with repetition. If you have any question so far, please kindly leave them in the comment section. If you are yet to subscribe to this channel, kindly click on the subscribe button, and I'll see you in the next part of this video.